Hey everyone, today we are going to talk about object-oriented programming in Python. Sounds fancy, but don't worry, I will break it down so it's easy to get. By the end, you will know what OOPS is, why it's super useful, and how you can use it in your own projects. If you haven't yet, hit the subscribe button and let's jump in. So we will quickly see what exactly is OOP and what is it used for, and the four main ideas of it, classes and objects, and then we'll jump towards the code. So first thing, what is OOP? Think about a recipe. You have one recipe card for baking a cake, but you can bake tons of cakes from it, right? OOPS works kind of like that. You create a blueprint called a class, then make lots of objects from it. It keeps your code neat and makes it reusable. Why bother with oops? So first, it saves you a ton of time. You write code once, then you use it. Second, it keeps your code organized, just like how a library organizes books on shelves. And third, it helps your projects grow without turning into a big mess. Sounds good, right? Now let us see these four main pillars of ops. First one is encapsulation. So it means keeping things hidden inside like a TV remote. You press buttons, but you don't see what's exactly there inside it. Mm. The second one is inheritance, like kids inherit traits from parents. In a similar way, classes can inherit features from other classes. Third is polymorphism. So it's just a fancy word for the same function acting differently depending on the object calling it. For example, like dogs bark and cats meow when asked to speak. The fourth one is abstraction. It's showing only what's important and hiding the complex stuff, kind of like a calculator, just giving you the answer without showing all the math. Let's move forward to classes and object. So a class is like a cookie cutter. It's a blueprint. An object is the actual cookie you bake with that cutter. Classes are just plans. Objects are the real things you make from those plans. So let's write a first dog class. This is super important to understand, so I'm going to explain you every single line. First, we'll write class and the name of the class dog and a colon sign. So this is where we start creating a class. We use this keyword class and give it a name dog. Just see this colon sign here. That's important because it tells Python, okay, everything indented under this is part of the dog class. Think of it like this. We are saying to Python, I want to create a blueprint called dog. Now everything we write inside this blueprint describes what a dog looks like and what it can do. So inside this, let us make a function and we'll initialize this by writing init and then the parameters. So let us name it as name and age. Okay, so this init looks weird, right? It has double underscores before also and after also, but it's actually super useful. This is called a constructor or initialization method. Every single time we create a new dog object, this init method runs automatically. It's like when you're filling out a form, the form asks you specific questions every time, right? Same thing here. Inside the parentheses, we have self, name, and age. The self comes first, it means this specific object. Then we have name and age, which are the values we need to create a dog. So let us write here self.name is equal to name and self.age is equal to age. These two lines are also very important. So we are creating something called instance variables. Let me explain what that means. When you create a dog named Bruno, we want Bruno to remember his own name and age. That's what these two lines do. For this specific dog object, if we talk Bruno, then it will store the name that was passed in. So if we create our object, let us create our object here. So for that, we'll write dog and then in double quotes the name of the dog Bruno and then the age because we have written here name comma age and here we're saying it's an object of this class dog. So if we write like this, then the name of the dog is Bruno and its age is 2. Likewise, if we write here Tom and here we say 5, then for Tom, self.name becomes Tom and self.age becomes 5. Each dog remembers its own data, they are completely separate. Bruno's age is 2 and Tom's age is 5. Changing Bruno's age won't affect Tom. Let us add one more function here. Let's say back and we have to write here self, a colon sign, and inside it let us print something. So we'll just write here self dot name and here we can say says foof. So a method is just a function that lives inside a class. This mark bark method is what the dog can do. So this is the class and this is what the dog can do. So let us create these objects now. I had already written it for example. So let us name it as dog1 and let us name this as dog2. So this is basically the blueprint and here we are creating the actual dogs and making them bark. So let us say let us make one more. So dog 3 can be Lucy and its age can be 1. And now we can call the bark method. When we write dog1 dot bark, we are calling the bark method on dog1. Python looks inside the dog class and finds the bark method, so it's here, and then it just runs this method. But here's the important part, it runs with self pointing to dog1. This is self, and this we have written here dog1. My bad, it's not brk, it's brk. So it points to dog1, and dog1 is here, which has details as Bruno and 2. Same thing happens for dog2 if we call this dog2 dot bark, and also for dog3. So let us run this and see. And you can see here the name has changed according to the object we made. So we first called dog1. So dog1's name is Bruno and it said Bruno, then says woof like this. Next is instance variables and methods. So inside a class we have these two main things, variables and methods. Let me show you the dog class again and explain. In this, the instance variables store data about each dog. When Bruno was created, it gets its own name Bruno and its self.age as 2. When Tom was created, it got Tom and 5 as its name and age. These variables are specific to each object. Bruno's name is Bruno and Tom's name is Tom. They don't share the same variable. Each has its own copy. So if you ask Bruno's name, he says Bruno. And if you ask Tom or Lucy his name, then they will give their name. So they remember their own information. Next, if we talk about the methods, then Methods are functions inside the class that define what the dog can do. Like we have defined here def bark, and this bark we have used here. So this is a function inside the class and this is called here as a method. So when we call a method on an object, it uses that object's data. So when we called it here, it went here and saw that it needs self.name, then it had gone to its object and find out the specific name. So let us add some more here. Like if we say eat, and we can write a print. We can print here self dot name is eating food. We can make one more. Let us say sleep, and here we will print self dot name is sleep. So look at this eat method. It uses self dot name. So when Bruno eats, it prints Bruno is eating food. Let us say here dog1 dot eat. Let us run this and see. So you can see it has been printed Bruno is eating food. When Tom eats, it will print Tom is eating food. So like this. If we say here dog3 dot sleep, then it has to print Lucy is sleeping. So you can see this here. So to summarize, instance variables are data that the object knows about itself, and methods are actions that the object can perform, and together they will make a complete object. Let us see now encapsulation. Encapsulation means keeping some information private and hidden. Let me build an account class and then I'll explain each step. So class name is account, and inside this we can initialize by writing def init, and then first parameter will be self, then we can give one as owner, another as balance, and here we will be writing self dot owner is equals to owner, and here we'll write self dot balance is equal to balance. This creates a basic account class. We can set the owner name and balance. But wait, here's the problem. Anyone can do this. Like if we say my account is equal to account, which is the name of the class, and we can just set one like John, and here can give the balance as 5,000. Then what we can do, this is an object, and next thing we can do is we can change the amount. My account dot balance is equal to example 1 lakh. So like this we can easily change this account. This was 5,000, but here we changed it to 1 lakh. That's bad. In a real bank you can change your account balance whenever you want. You have to go through paper process. So um what can we do is we can use the encapsulation here. We can make the balance private using double underscores. Here we'll put double underscores like this. So this is now private one. And if try to change this, then Python will give an error. But we'll still need to let some people add money to their account. So for that, what can we do is we can make one more function, deposit. And here we'll give the parameters as self and amount. Okay, and we'll put a colon sign here. Next, we'll see if the amount is positive, then we'll just add it to this self.balance. Otherwise, we'll print that cannot deposit negative amount. So if amount is greater than 0, self.balance plus equal to amount, and we'll just print here deposited amount, and here new balance self dot balance, and here will be else that it should print cannot deposit negative amount. So now the only way to change the balance is through this deposit method, and inside the method we already checked that if it's negative it will print this error message or this message. By the same thing, we can also add one withdraw method here. So if we say this withdraw, and the first parameter will be self, and second we can give as amount only. And here we'll again check several things like if amount is positive and if it's there in account or not. We can't withdraw the more account than already present in our account. So we'll just check if it's there. So amount is less than equal to self dot balance. And here we'll just subtract it. So self dot balance minus equal to amount. And then we will print withdraw amount and the new balance. So the new balance will be self dot underscore underscore balance. Else, what should be printed? Cannot withdraw. So here's the same idea. We can withdraw, or the people allowed can withdraw through this method only. And here we have also checked whether enough money is there to be withdrawn or not. We can even add a get balance method so that we can see what amount is present here. So for that we make one another function get balance, and the parameter will be self, and we can just return self dot underscore underscore balance. So it means that the value of self dot underscore underscore balance will be returned, and so when we call this method then the value of the balance will be printed. We can only access the self dot underscore underscore balance value through this method because it's private, so we can't directly access it. Now let us use this code, and here we'll write my, let us just comment this, and here I'll write my account dot deposit. So let us deposit some amount, let us say 2000, and if we run this you can see deposit is 2000 and new balance is 5000 plus 2000 which is 7000. If we want to withdraw, then we can simply write here withdraw maybe 1000 rupees, if we just see the output, then we withdraw 1,000 rupees and the new balance is 6,000. Okay. If you want to print the balance, so my account dot, and the method here was get balance. So I'll just write here get balance. So if we see this, say we got 6,000. If we directly want to change it, let us see. Uh, if we run this, so we can see that method is not did not get it get not get any output, and we just have the output for these three. Our one was, and this is because this my account dot balance is not there. It's my account dot underscore balance. So let us put here two underscores and let us see. So again, you can see there's no change because we can't directly access this if it's a private method. So basically, this encapsulation protects our data. Like we saw here, we can't directly change our balance. There are rules and checks. So this balance is protected by the methods we created. Next thing is inheritance. If we talk about inheritance, this is cool because it saves you tons of code. Inheritance means creating a new class based on an existing class. The new class gets all the features of the original class automatically. So here's the idea. Let's say we have a general animal class here. So all animals have general things in common like dog, cat, and bird. They can move, eat, and sleep. But the animals are different, right? Like dogs bark, cats meow, birds fly, like this. So without inheritance, we would have written the code like let us just comment this. So here let us write new class. Um, First let us name the class as dog. Then let us make one function move. So def move self is the parameter given it. Print dog is running. Let us make more function like eat, and we can write here print dog is eating. And if we say another function back and we print here foo. Now let us make one another class for another animal. Let's say cat. For cat, we'll say cat is moving or running, whatever. And we'll make another eat, and then we'll print here cat is eating. Then another will be bark, but the cats don't bark. So we have written here meow, and we'll just print this meow here. So like this, you can see we're writing this move, eat, and this again and again. This is so much of repetition. So with inheritance, what we can simply do is we'll write here one parent class, which is animal. And inside this, we will define this move and eat, which are the common functions for this dog and cat. So we'll write here move self, and here we will print animal is running. Then we'll make another eat, and here what we'll be printing, animal is eating. Then what we can do is we can make another class named as dog, and features will inherit from animal. So dog, and in parentheses we have written the name of our parent class, which is animal. Let us comment this. Yeah. So in this we'll define this bug because this is different for cat and dog. So we are defining it inside the dog class. Similar to this, we'll also make one another cat class, and we have again inherited the animal functions like move and eat here, and we'll just define here meow. We'll have to print here meow. Okay. So you can see the difference. This is dog, parenthesis animal. Dog is an animal, or dog inherits from animal. So dog automatically gets move, eat, and it doesn't have to write them again like we were writing here again and again. So it just of that we have added a unique feature back. Same with cat, it inherits this move and eat, and we have written a unique feature here inside the cat. So let's make objects. Let us say dog. So this is an object dog, and this is the name of this class dog. If we say dog to move, to sleep or eat, what function we have written? We have written eat. So dog dot eat. And similarly, if we write it for cat, and then we'll say cat to move, then cat to eat. If we run this, you can see animals running and animals eating. It has been printed. Now if we say dog to bark and cat to eat, so dog dot bark and cat to meow. If we run this, you can see this is printed. So you can say both dog and cat can move and eat because they inherited those methods from animal. But dog can also bark and cat can also meow. So here's something cool. Let's say we want dog to have its own custom eat method. So here we'll just add def eat self. Inside this we'll write dog is eating bones. If we write it like this, now if we run, you can see it has overridden and this dog is eating bones has been printed. So this is printed instead of animal is eating. We have overridden the method here. But if you have an animal object or a dog, it prints animal is eating. Like this cat was an object, so it still says animal is eating. So we can customize methods and child classes while still inheriting the basic structure from the parent class. So let us see one more example here. Let us make one another fresh class. So better comment this. We'll say class animal, and here we'll say to speak. So we can print some sound. We'll make one another class named dog, inheriting from animal, and here we'll again say to speak, and here we can print woof, and here we'll make another cat. Again, we'll inherit the features from animal, and we'll make here df speak self, and we'll just print here meow. So what's happening here when a dog animal, this has been written, means dog inherits from animal, so dog automatically has the speak method. But we are giving dog its own speak method, and same with cat here. So cat inherits from animal, but we have given its own speak method. So when we'll just create the object, dog is equals to dog, cat is equal to cat, and then call them dog.speak, cat.speak. So you can see woof and meow is printed and some sound is not printed. So this is how we have overwritten the method. Next is polymorphism. It's a big word, but it just means the same method name doing different things. Look at what we did with cat and dog. They both have speak, but they speak differently. That's polymorphism. Here's what we can do is just can comment this, and we can write here list named as animals, and here inside it we will add cat and dog. These cat and dog are these cat and dog. They are the objects of these main classes. Okay, and what we'll do is we'll iterate through this list, that is for animal in animals, or we can also write for in animals any way we wish to. Then we'll say animal dot speak. If we print this, you can see woof and meow is printed. So now we have looped through the animals list and called speak on each one. We don't have to see whether it's a dog or a cat. We just call speak and each animal does its own thing automatically. So it is helpful, like if we have a zoo with 50 different animals. Without polymorphism, it would be very difficult to write 50 different statements. So with this simple loop, we can just make our task easier. So alright, let's bring everything together with a student class that manages students. So let us comment this. Name of our class is student. Um, Let us make two functions here. First one will be to initialize it. Self, comma name, comma role, let's say. Then a colon sign will be there, and we have to define it. Self dot name is name. Self dot role is role. Role is roll number here. And we can make one more function, display. So display will give the parameter self, and we can just print the student and the roll number here. So student will be self dot name, and then we'll print the roll number. So roll number will be self dot roll. This is simple, but it shows all the concepts. The init setup each student with their own name and roll number, and the display method shows their information. So let us see, let us create these objects here. If we make a list, students, and we just add the objects in this list. So what we are doing here is we are directly making an object of the class and adding them to this list. Like this student a comma 1, we can do it like s1 is equal to this, and then we can write students dot append s1. So like this object s1, which is actually the object of this class student having name as a and roll number as 1, will be added to this list. But instead of doing this, we can directly write like this. Instead of giving it another name, we directly add it to the list. Let us write here roll number 2, and the name is B, and here roll number 3, name is B. So we can just use the for loop for student and students. We can display the list of the students. So student dot display. Let us run this, and you can see the student name and roll number for all the students that we had added is printed here. So that was all for this video. Like, share, and subscribe to the channel if you found this helpful. Thanks for hanging out. See you next time.